Okay, class. So I did check the answer, and this answer is indeed correct. I also checked to see if there was a priority of rational numbers and irrational numbers. Honestly, I don't think there is anymore. So you could put them in any order, but just do the order that makes the most sense to you. Um, and as always, if you feel like you want to take a break or you want to replay the video, please feel free to do that. These lesson problems are very good practice problems for you, but and you want to try them. It's really good experience to help you prepare for the homework assignment. But I also know that this is decently long, so if you want to split this up, if you want to do this over a period of time, feel free to do that. Okay. Um, Okay, so let's start. We have one more page to go. I'm going to try my best to do a good explanation of each problem, but we'll see how far this goes. Okay, you can kind of see how the level of difficulty is starting to really ramp up. I thought number 14 was an excellent question, and I'm looking at 15 already, and I feel somewhat intimidated by the 192. Okay, so if you still enjoy having the square root on the side, please feel free to do that. Okay. Always have the squares that I've written on the previous page, always have them on the side so you can kind of use this to help you with the square root of 192. Let's go ahead and do that. So the square root of 192, there are certain patterns that you can kind of use. You know that it ends in a 2, so you can't really, well, first of all, you can't really use any of these as your factors, right? 4 potentially could end in a 2 if you just multiply the 4 by a 3. And that immediately tells me that that's the answer, right? Obviously, I could have used 4, but hopefully and obviously you could still use 16, but these two are not good choices. You always want to use the largest square as a factor. Okay, so I know that this is the square root of 64 times the square root of 3. The fact that this is already simplified makes me very happy because I know that this is just 8 root 3. Okay, and now I'm going to use square root of 72. I hope that one's decently obvious. That is just the square root of 36 times the square root of 2, and that gives me 6 root 2. Okay, so we're subtracting. And then our last one is 75, which is just the square root of 25 times the square root of 3, which is 5 root 3. And we're adding. Okay, so this is where we can kind of shuffle a little bit. We know that we could combine these two and then just attach this negative 6 square root of 2 on the side at the end. So 8 rad 3 plus 5 rad 3 is going to be 13 rad 3 minus 6 rad 2. This whole entire lesson class has been excellent. It's very well written. It's definitely something that you want to be comfortable with. Uh, Moving forward as you enter high school, you're about to enter ninth grade math. This is something that you really need to be comfortable with because we do this all the time in algebra 2. We do this in trig. The reason why we work with these numbers a lot, class, is because when you're finding the missing value or missing side of a triangle, you definitely use radicals and squares, and you kind of use the inverse operations a lot. And that actually is the next lesson, which is on the Pythagorean theorem. So this is the algebraic side of all of that, and you definitely want to be comfortable with this. Okay, so number 16 looks challenging. There is a radical on the bottom that we have to rationalize. I think the first thing we have to do is simplify this square root of 4. So this becomes 2 minus 2 root 9. Ooh, I should have simplified this. This is just 3, isn't it? So I should have just done 2 minus 2 times 3, which ends up being negative 6 with a 2, and that's just negative 4. Okay. Now you just have to rationalize the denominator, and you just multiply by square root of 2 on both the top and the bottom. And this ends up being negative 4 root 2 over 2. But I also hope you're starting to see that these two numbers must also be simplified, right? It's just like the fraction 4 divided by 2, and you end up with final answer of negative 2 root 2. All right, we have one last page. May run out of time. I only have about 10 more minutes, so I'm going to do my best to go over as many problems as I can. Okay, so I'm going to move a little bit faster, and now I'm just going to do it and try to show my mentality with all of this. Okay, so let's multiply and distribute. You get square root of 64 plus the square root of 20. This we know is 8. This square root of 20 is going to be square root of 4 times square root of 5, which is 2 root 5. So final answer is 8 plus 2 root 5. Okay. This is really the time for you to challenge yourself and practice. Maybe you want to pause this video right now and just do this on your own, and then check your answer. I will be posting the PDF for this, and you might want to just check. This is just good practice now. Okay. Square root of 3 times 4 square root of 3 is simply, you can just multiply these two together, and you get 4 times 3 plus the square root of 15. And this is really just 12 plus the square root of 15. Okay, that's really nice because the square root of 15 is already simplified. Okay, number 19, you want to rationalize the denominator. So you're going to have to multiply the top and the bottom by the square root of 6. And you end up getting square root of 18 minus 9 root 6 all over 12. It becomes 2 rad 6, and that actually becomes 2 times 6. Okay, but the square root of 18 is not simplified. That's the only problem that we have right now. And the square root of 18, I think at this point, you could even just say, we know that that's 3 square root of 2, because the square root of 18 is 9, square root of 9 times square root of 2. So we know that that's 3 root radical 2. And we know that this is minus 9 radical 6 all over 12. So then the final thing you have to do is you just have to simplify 3 over 12 and 9 over 12, right? 3 over 12 is 1/4, and 9 over 12 is also, you could just divide everything by 3. So you end up, the final answer is square root of 2 minus 3 rad 6 all over 4. Really, really good question. 20. Simplify the square root of 12. You get square root of 4 times square root of 3, which is 2 rad 3. Then you multiply that by this 2, and you end up with 4 rad 3. So then it's 5 plus 4 rad 3 minus 3 minus. Notice how I'm distributing this negative. Definitely want to be careful of that. Distribute the negative, right? Square root of 48 is just square root of 16 times square root of 3. So it's 4 rad 3. We have a 4 rad 3 with a negative 4 rad 3. That actually cancels. And then you end up with 2 as your final answer. Quickly double check that.